Today on the Y of Math, I'm going to be demonstrating how to take the standard deviation of a continuous function. Now, the square of the standard deviation, the variance of any set, is equal to the difference between the individual components of the set and the mean of the set, quantity squared, divided by the number of elements in the set. Now we can distribute the square using the normal formula. Gives us sum from 1 to n of x sub n squared minus 2 times x sub n times x bar plus x bar squared, all divided by n. But we can simplify this by breaking down the individual components. The sum from 1 to n of 2 times x sub n times x bar is simply 2 times x bar squared times n, because we know that the sum of all the elements in the set is equal to the mean times the number of elements in the set. Likewise, summing up the squares of each component divided by n is simply x squared bar, the mean of the squares. And summing the means just gives us n times x bar squared. So that gives us sigma squared equals n times x squared bar minus 2n x bar squared plus x bar squared times n, all divided by n. That simplifies to sigma squared equals x squared bar minus x bar squared. The variance is equal to the mean of the squares minus the square of the means. And to convert that to a standard deviation, you just take the square root. Now, how do we calculate the mean of a function? Well, the mean of any function is simply the integral of that function over the interval of a to b divided by b minus a. B and a being arbitrary boundaries, whatever defines the limits of your function. And this same formula works for finding the squares, or the square functions average, and yeah, that applies in general. And that is how you generalize a mean and a standard deviation to continuous functions. That's all for today. Remember to like, share, and subscribe, and leave any questions in your comments section. Thank you.